Alright, so this video is intended to help you make a graph, and we're going to do it in the context of this question. So when we're plotting a graph, we have to look at what we're being asked. So it's saying plot a graph of mass against gravitational field strength. Okay, so the way that's phrased to me is that as you change the mass, how is the gravitational field strength change? So it's almost always the first one is going to be your x, and that'll be your y. So radius doesn't matter for this graph. Okay, so the first thing that I need to do is to set up my axes. Okay, so I'm going to give myself a little bit of space. You want to use up at least half of your available graph paper in terms of the amount of space. So I'm going to do my axes along here. Always use a ruler because you don't have an iPad that's going to snap to a nice straight line. Okay, so I'm using the major grid lines here. So the next thing I need to do is I need to look at, I'm going to label my axes. So what's going to go on my axes? So it's important that we have so down here, because it's mass, and you can get your headings right from your table. So it's mass in times 10 to the 24 kilograms. Okay, so what that means is that if I read off a 1 from here, that means that it's actually 1 followed by 24 zeros for kilograms. Okay, and my last one, I'm just going to shorten it to GFS because I don't want to write it all out. Gravitational field strength, and that is in newtons per kilogram. So remember, your labels can come right from there. So now I've got to set up my axes. So I've got to think to myself, what's the biggest numbers that I need? So for gravitational field strength, the biggest number that I've got is 23.1. So my maximum value for my graph needs to be at least that big. And I've got 1, 2, 3, 4, 5 big squares that I can use. That's actually really convenient because if I go 25 up at the top, that's bigger than my 23.1. And because I've got 5 things, that actually divides really nicely. So it's really important that you always go an even number. And you almost always want to start from 0 and you go evenly. You don't want to do the thing where you start at 100 or have a 0 and then put the squiggly line and start. Try to start from 0. So that's going to make that 5, that 10, that 15, and this 20. So I need to go up to at least 1,900 kilograms. I'm going to break convention a little bit here, and I am going to put 2,000 over here. Okay? That makes, I've got 5 of them, so I divide 2,000, that's 400 for each thing. So 400, 800, 1,200, and 1,600. Now, normally you'd want to go up in either 1s, 2s, or 5s, or like multiples of 10. So like you can go up in 20s and 50s. You don't normally want to go up in 400s, but in this, it'll be fine for this case. Okay? That also means that every little square is worth 40. So I'm going to start plotting my points. So I need to look 1900. So 1900 is going to be about halfway between here and here, and it is 23.1. So that's 21, 22, 23.1. So my point is about right there. Okay, so that's going to be close enough for my Jupiter point. So read along the bottom, okay, to find 1900, and then go up until it reaches 23.1 on the other side. So now let's do Saturn, 570. That's 480, 520, 560. So it's that line there. And it is 9.0. Okay. And convention is to do a cross. I'm going to erase my tracing lines there. Okay. And then we've got Uranus at 70, and it's 8.7. And then Neptune at 100 is 11.0. Okay. No, my point there is a little bit off. Okay. Should have been a bit farther to the left. Okay. And 11. I should probably switch back to my pen tool. Okay, so it's going to be right there. So, really, if we look at this, it's really hard to do a line of best fit for this because there isn't a real obvious pattern. Okay, I mean, it clearly is, we've kind of got it going up. Okay, however, there are planets that don't really fit because Neptune is so much bigger, so much higher than what Saturn is. So, I mean, we could sort of say that if you double the mass, then the force of gravity will also double. But I mean, we can just look at this and see that that's not what's happening. So, can we use this to back up the data? No. No, we cannot. No. There is an upward trend. But you can either say that Neptune doesn't seem right or Saturn is wrong. Okay, and the reason for this is that planet radius matters. Okay, so the thing is, Saturn and Jupiter are really almost the same size, but Jupiter is much heavier. That means that there's more stuff pulling at the same distance. Okay? The last graph here, it shows a graph of mass versus weight of objects if they were on the surface of Saturn. Draw a line on the same graph for mass versus weight on Neptune. Well, we know that if it's 0, it's going to be 0. And remember that weight is mass times gravity. So if I pick a point, so I look at Neptune, the gravitational field strength is 11. So if I go to 10, say, well, 10 times 11 is 110. And then I just draw with a ruler, please. I don't have a ruler I can use on my iPad, but with a ruler, draw a straight line that goes through it. Okay? So it should be a ruler, goes straight through it. And that's all it was for that question. All right, so I'd like you to try, on a separate piece of graph paper, try to redo that graph. Okay? So try and do that graph on your own now.